kidding. Hold up, you got me woke up. The way you roll that, sticky like okra. Just let me coach ya, show you about my culture. It's a late night show like Conan. Bitch, the party ain't over.
Alright, Biocats, I'm gonna rush this because class ended and I don't use time well. Light reactions, let's go. Let's get this started. What's going on in light reactions? Let's look at it. So, right now we're looking at the membrane of the thylakoid. Here we got the stroma, that's the cytoplasmic thing. Thylakoid, that's what's going on there. Alright, you got not a lot of H pluses outside, a lot of H pluses inside. High pH, low pH. You got that? You should know that. I gotta film. It's fine, it's not a big deal. So, you got your, as you know, if you remember from the previous video I made, you got E coming out of that other reaction center, blah, 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 from the photon. You should know that. I'm not going to elaborate it. It comes into here. Also, we have a water splitting enzyme on this thing called PS2 or P680, because 680 is the wavelength of light that it just loves, all right? Anyway, PS2 is easy to remember. So you have a water splitting enzyme. You got water in there. It splits water. Through some miracle of redox magic that you don't actually need to know, you get an electron. It's all going in through here. You got those antenna things that lead to the reaction center, and it's like, whoa, I know this already. You do know this already. You know all of this. Shh. That's totally fine. Go for it. I would love if you did that. Anyway, so you go to the thing, and it goes to reaction center. You're like, Andy, what happens to the reaction? You know this. Redox happens, and that's how you get this electron, all right? So you got an electron, and it goes to this thing called the primary electron acceptor. Think NAD+, except it's not NAD+, because that's not how bio works, guys. So this literally does the exact same thing NAD+ does, and you take it to, that's right, ETC, which you should already know by now. I'm not going to explain what happens to ETC, but the point is, 4 electrons move in against the gradient, because why not? So you got 4 H pluses in here, and it's like, whoa, it's really low pH in here now. Even more low pH than normal. And what happens in the ETC? That's right. We got another electron left over from the ETC, right? By some miracle of redox again, right?
Yeah.
And you should know why this happens, because I don't know. You should know, because this is like the last stuff we learned. And it's going to go through, that's right, another thing like PS2, except this time it's called PS1. But you're like, Andy, these are reverse in order. Yes, I know they're reverse in order.
Andy, don't you have
I don't care about this. So it goes through the PS thing and does the exact same thing here. So once again, you should know all of this, because this is a review video, all right? And then it goes to this thing called ferredoxin. Andy, what's ferredoxin? I don't know. It's not an enzyme, so I don't know what it is. It's a molecule, okay? Except that. So I wrote an asterisk here. So let's review exactly why I put an asterisk here. Because if ferredoxin, this is the whole like, in this unit, the theme is like regulation of ATP. And in the end product is eventually going to be ATP. So, one of 2 things will happen. Number 1 is something called cyclic phosphorylation, where the electron in ferredoxin will see this, will be like, oh man, we need a lot more energy. Like, damn, we need more ETC to happen. So what's it going to do? It's going to send the electron all the way back to the first ETC, and it's going to go all the way back to ferredoxin again. This is cyclic phosphorylation because it happens, like a cycle. Get it? Yeah, it works. The other one, non-cyclic phosphorylation, surprisingly, is where it goes to the other ETC that I'm about to review with you. Oh, and it's also straight across here. And this is non-cyclic, and then it goes to the NADP reductase. So what happens there? We're going to do it right now. Ferredoxin, you had an electron, goes through the second ETC, which is smaller and less awesome as this one, and you only pull in 2 hydrogen ions against the gradient. Why? Because it's smaller and more crappy. Okay, deal with it. So now it goes to this thing called an NADP reductase. What is an NADP reductase? JB, is it an enzyme?
For what?
NADP reductase? An enzyme. Yes, finally, something that's an enzyme. It goes here, and then you get NADP+, and that's right, when you add an electron, what does it become? NADPH! And that goes to dark reactions, which I hope to cover, but maybe not have enough time. Anyway, also, while all this is happening, you remember, ETCs, what do you get? You get energy. And where's that energy going? It's going here, to the ATP synthase that happens to be located here. You know why? Because ATP synthase is literally everything. So look, you get the H plus out, and it spins the thing, and boom, ADP becomes ATP. What is ADP and what is ATP? If you don't know this, you're going to get a D in this class, like actually. Alright, thank you. That's my video. 4 minutes, really good time.